Okay, so order of operations is one big topic for this week, along with percentages. So just a reminder on the order of operations, first thing's parentheses. Second thing is exponents. Let's freak out. Exponents. Third thing is multiplication or division, kind of depends. And that's going to be done from left to right. Fourth option, addition or subtraction, kind of depends. And that's also done left to right. And the thing about the order of operations, although they have this precedence here that you're supposed to do parentheses first, then exponents, it's not always a 1, 2, 3, 4 process. It kind of flows depending on the problem. Okay, so you kind of jump around in this depending on how complicated the problem is. And so we're just going to play around with some expressions and get used to that. And again, the multiplication or division, sometimes division's first. It just depends on which one happens in the line of events. So remember when we were cleaning up those crazy ratios for unit conversions, and I would do like 4 or 5 at a time? We could kind of flow around with that, doing stuff in the numerator first and the denominator. There were actually options on how to pull that off and still get the same number. Okay? So although we have the order of operations that says you got to do things in this way, there are other ways to circumvent it depending on rules of math. Okay? So I'm just going to make a note of some of those ways we can circumvent the order of operations. So some things that allow us to circumvent the order of operations, some alternative stuff. We know that it doesn't matter the order you add in. Okay, anybody remember what property that's called? What's that?
Property.
No, it's got a special name, starts with a C. It's called the commutative property. So 2 plus 3 is the same as 3 plus 2, right? It doesn't matter what order you do it in. So all that, I can kind of violate the left to right procedure because I know it doesn't matter what order I add stuff in. So there's 2 properties of addition that kind of help here. This one I've showed here is what's called the commutative property. And think about, you know, I commute from home to work. You guys can commute from home to school, and then you got to get yourselves back. So commute means to physically move the numbers. Right? So I pick up the 2 and the 3, and I displace them on opposite sides of each other. There's another kind of similar sort of property that's called associative. That's when we change the order with parentheses. So if I had 2 plus 3 plus 4, order of operations says you should do it from left to right. So I would do 2 plus 3 first. Right, so I could put parentheses in there, remind people to do the 2 plus 3 first. So 2 plus 3 is 5, plus 4 gives me 9. So that's following the order of operations, and I just threw the parentheses in there just for the hell of it. I didn't have to put them in. However, I could have done it a little different. Even leaving them in the same order, I could have put a parentheses around the 3 and the 4, saying, hey, do those first. 3 and 4 is 7 on a good day, plus that 2 we left behind. It's still 9, right? We get the same answer. So whenever you can shift parentheses and still get the same answer, that property is called associative. And you can't do that with every operation, right? That screws up subtraction. It screws up division. But it turns out you can do both these things, commutative and associative, whether you're in addition or multiplication. So I'm just going to make a note up here. Switch to blue or multiplication. And I'll show a couple of examples of that. So there's lots of different things we do with numbers. The main things are, right, we add, we subtract, we multiply, we divide, we use powers. Addition and multiplication are nice. I can move them around, I can do them in different orders, I can violate the order of operations and still be okay. But most of the time I have to stick to the order of operations. So I'll show multiplication next. Just by the way, I'm not going to test you on whether you know the word commutative or associative. If this was an algebra class, that'd be part of it. But if you ever want to kind of get those words down, commute means physically move, like I commute to work. Associate is like I associate who's next to me. So Elizabeth's next to me right now. She and I can associate. She's right next to Tristan, so those two can easily associate, right? So association happens with things that are already next to each other. All I do is change how they're grouped, okay? So association is about grouping, commutative is about moving things around. We can't do that with subtraction. We can't do that with division. But multiplication, we know, 2 times 5 versus 5 times 2, they're both 10, doesn't matter. And if we think about association, if I have 2 times 3 times 5, order of operations says you should do 2 times 3 first. So 6 times 5 would be 30. Still nobody online. Where are those two today? Alternatively, if I leave those numbers in the same order, 2 times 3 times 5, associative property says, hey, you can change the grouping and it still works out okay. 3 times 5 is 15, times that original 2 is still 30. It works, we're good. Okay, one other thing I'll go over for now that we can kind of cheat the order of operations is the distributive property, which we talked about before. A week or two ago. So if I have 2 times 3 plus 4, order of operations says I got to do what's in the parentheses first. So 3 plus 4 is 7, times 2 gives me 14. The distributive property says, hey, well, you can do this a different way if you want. Distributive property says you can take that multiplication by the 2 and bring it inside the parentheses. So I could say, hey, this is 2 times 3. And I can do the 2 times 4. So the distributive property gives me another option. If it works, well, let's see. 2 times 3 is 6. 2 times 4 is 8. 8 and 6, yeah, pretty sure that's 14. So it does work. So both sides are still equal. So distributive property gives me a way to circumvent the order of operations by just throwing that 2 into the mix there. And Robert had asked, like, well, which way is better? The first way it's written or the second way? And it just kind of depends on the situation. Sometimes it's better to leave it this way and deal with it. Sometimes it's better to put it that way. All right. So let's look at one of your prep problems. All right, so let's see. According to the order of operations, what is one correct way to solve this problem? Now, again, there are usually with a complex problem many ways to do it. So let me screenshot that sucker, and we'll give it a try together. What's that? Yeah, that's what I'm gonna. Oh yeah, I'm gonna zoom it in before I screenshot it. Thank you for reminding me. Scoot over. So before we even look at those options, we're just gonna try the problem. So I'm just gonna copy this part, and let's walk through it together, and then we'll look back at the options and see what we can do. All right, so order of operations says you should do what's inside parentheses first. So I got to do the 3 plus 6. So usually what I do when I'm attacking a big problem like this is I just do it one step at a time. So I do one part and then I copy everything else down. Okay, so 3 plus 6, 9. And then I bring everything else in. So I have an 8 plus 6 times that divided by 2 and then minus 4.
So because you don't have to put the 9 in parentheses.
You could leave the 9 in parentheses. The reason I took it off is because I did what was inside the parentheses, so I didn't think I needed them anymore. And so usually when I do clean up the inside of parentheses, I can drop them. Okay? Leaving them there, just still a multiplication. So you can go either way there. All right, so next thing in the order of operations, I might look for more parentheses. There aren't any. Then I drop down to exponents. No exponents. Next we do what? Multiplication or division, and it just depends on which one's first, left to right. So looking at this right here, I have a string of multiplication and division I have to do right there. And it recommends going from left to right. Okay. So switching color, 6 times 9 is 36, 54?
54, I think.
54, let's go with 54.
Yeah, 54.
Yeah, because 6 times 10 would be 60, back up 6, and there's 54. Okay, and then we have to divide by the 2. So I'm going to complete this thing before I copy the other stuff down. Actually, no, I better copy it down so that it looks more like those options we have. So I did this part. Now I continue to do the division. Half of 54. 27 sounds good. And then I bring down the other stuff. And then what should we do? Yeah, left to, keep moving left to right. So then I would say, okay, 8 plus 27 is 35, I think. Oops, that didn't come out right. 35, and then we can subtract that 4 and get a 31. So how can I check this? Well, I could whip out my calculator, and in some calculators you can type that all in one shot and hit enter. Like on my Google calculator I can do that. On my spreadsheet I can type that just like I see it, and it'll just come out. So just whip out a calculator right now, see if you can come up with the 31 by just doing it on your calculator. Now, as often as possible, remember when you do calculations, I want you to write them on paper as well as do them on the calculator. You just wrote this one on paper. See if you can whip it out on your calculator. You got 31 on yours? Now on yours, can you do it in one shot or do you have to do it in stages? You can do it in one shot. That's cool. Yeah. So if you don't know how to use your calculator to do it in one shot, I'd recommend either visiting with me about it, oops, or getting a new calculator if it's not possible. All right, so let's see. I'm going to whip out my Google calculator here. 2 plus 2, give me my Google calculator. All right, let's scoot you over a little. Whoa, not that far. Okay, there's enough of my Google calculator. All right, so in Google, I should be able to just type it. 8 plus 6 times parentheses, 3 plus 6, close parentheses, divide by 2, subtract 4. I think that looks like it. Equals 31. Okay. Otherwise, do it in stages and use your calculator. All right. So then the tricky part of this problem is looking back at these options. What's that? You got 25? Okay, so you must have typed something wrong or your calculator's misbehaving. And that's one of the wrong options they give here. So there's a wrong step in that one. Are you using an iPhone calculator? Yeah. Oh, yeah. So the iPhone calculator is a total pain in the butt. In the iPhone calculator, you have to do it in stages like that. You can't easily type it in one shot. Okay? So that's a problem. So the only way to do it on the iPhone calculator is to, in pieces, do it. You can't do it in one shot. So, sorry about that.
I like doing in pieces because they like sort of like check myself.
Yeah, I think it's a good idea to do it in places because often, you know, typing a big thing like that, it's hard to double check you typed it in exactly right. Yeah. So doing it in stages is a good idea. All right, let's take a look at the options they gave us here. And I don't think I can blow this up anymore without losing it. Oops. Maybe. No, I lost my scroll bar. Can I arrow over? Oh, there we go. Okay. All right, so the first one, let's see, what did they do? It looks like they only multiplied the 6 by the 3. Distributive property says it should be times the 3 and the 6, and they skipped that. And notice they got a 25 in the end. Okay, so they tried to multiply before adding, and they didn't use the distributive property right, so it got screwed up. So that one's not right. This one has the right answer. That's the only one with the right answer. So I think I'd pick that one.
Just clicked on the 63.
Oh, I hit the wrong one, yeah. Okay, let's see what's wrong with the 63. What did they do wrong here? They added before they multiplied. Total violation of the order of operations. Order of operations says you got to do the multiplication first, but I can't do that multiplication until I do that addition. Okay, so that was a problem. How about the 29 here? What went wrong? Ooh, there's a weird symbol. I think that's supposed to be...
Where did 4 go?
Oh, I think they did 2. Oh, I bet that's supposed to be a negative.
Yeah.
I bet they went 2 minus 4 is negative 2. But then it disappeared here. Okay, so this is just crazy stuff here. Interesting. Oh, I see what happened. No, I don't see what happened. Okay, so my guess is they said 2 minus 4 was 2. 2 goes into 6 3 times. Yeah, so this is definitely a problem. They're violating the order of operations and they're not getting the right answer. How about this one here?
They divided by 2. Oh wait, no, they divided by 6 by 2.
Yeah, they took the 2 into the 6 and got the 3 there. And it looks like they did the same thing here. They, instead of subtracting, they took the 2 into the 6, got a 3, but then it doesn't work, right? So that's, again, a violation of the order of operations. Don't get the right answer. So the point of the order of operations is so that we all get the same thing, that we don't disagree on what's the right answer. There's got to be just one answer when you do arithmetic. All right, so I'm going to reload this and let you guys try it without me. How do I reload it? Submit. And ooh, I hit the wrong. Oh, I hit the wrong one. Right, I knew that. Try a similar question.
Give you the same question.
That's the same question.
Yeah, it gives you the.
Oh man, it didn't shuffle it.
Question, the same.
Yeah, sometimes these are not automated very well. Okay, I'm going to make one up for you. You guys try it, and then we'll do some tax stuff. All right, we'll keep it relatively easy. How about 5 minus 2 times 6? Okay, super short 5. Not super short, relatively short. According to the order of operations, what is the right answer here? I think we got to do a multiplication first. So 2 times 6 is 12. Then I can do 5 minus 12. So I had 5, but I lost 12. So that's an overall loss of how much? Yeah, so it should be negative 7 in the end.
So you can do negative 2 times 6 and get the same answer.
Yeah, so that's a good point. So I'm just going to rewrite this a little bit. In algebra, it's nice to sometimes consider subtracting, adding the opposite. So I could say that's 5 plus negative 2 times 6. Negative 2 times 6 is negative 12. 5 plus negative 12 is still negative 7. So that would be another way to think about it. Okay, next one is going to be order of operations from a story problem. So I'm going to give you a story and see where we go. New page, there we are. Okay, so George won $97,000. He must pay taxes on all but the first $10,000 he won. At 15%. So we want to figure out how much tax he has to pay. So this is an order of operations problem. So I got a few things going on. got this big amount, 97,000 that he won. He has to pay tax on it, but not on all of it. First $10,000 is tax-free.
There's a problem like this one.
There was, yes. All right, write something down, see what you can come up with, then I'll write down my version and we'll go over it together. I'm going to do this in two different ways.
This one's easier than the one on the test.
What's that?
This one's easier than the one on the test.
What do we do with a percentage once we have a base amount? Multiply. Yeah, so we have to take 15% of that 87,000, which means we have to multiply 0.15 times 87,000. And then that's going to give us our new amount. Does anybody have that dollar amount?
13,000.
13,050. There's the tax he has to pay. Anybody else get that? I got that. Not that.
No, I did, but
Okay.
if I did it in a different way and still got the same answer, is that okay to do
Yeah.
it like that? Okay.
Yeah. How did you do it? Can I see?
I did this, I learned in middle school, it's over of equals percent over 100.
Oh yeah, that's a great way.
Yeah.
Yeah. So another way to deal with percentages, especially if a different value is missing, like the base amount, usually we have something like some amount is some percent of some base. And then the way you can set it up is you have, let's see, how did you put that? Your is over your of equals the percent over 100. So for us, we don't have the amount yet. That's what we need to figure out. Of is our base, that's the 87,000. Equals 15 out of 100 because that's what 15% is. And then you can use that fraction to go ahead and solve it. Yeah, that's a great way to do it too. So a couple ways to do it from this way. You can do what's called cross multiply and divide. Is that what you do?
Yeah.
Okay. So from here, I would cross multiply and get question mark times 100 equals whatever 87,000 times 15 is, which is going to be something like 1305000. Did I get that right? You read too many zeros there.
No, you got it.
Got it right. And then to finish it off, I would divide by the 100.
But why do you subtract the 10,000 first?
Yeah. So
If it's not.
yeah, you have. So before I could do this, I have to subtract the 10,000. And again, the way I stated the problem here, he has to pay taxes on all but the first 10,000. So $10,000 is tax-free. That doesn't count.
Okay.
So before I deal with the percentage, I got to deal with that part right there. Okay. There's another way more complicated way to do this, and I'm not even going to go into. But so that's another way. That's a second way to do it. A third way to do it is just to kind of think about it. Oops, in one shot. Did I get my slides out of order? And so I could say the first thing I have to do, I'm going to put in parentheses, and that's to take the 97,000 minus the 10,000.
Okay, I was like doing an order of operations, but I was going in the order that it was like written in, so I did the multiplication and the subtraction.
Okay, so I'm gonna write it down that way. So I have to take that subtraction, but it's got to be in parentheses because it says that part doesn't count. Doesn't count means I got to take it away, and then I'm gonna have my 15% out here. So if I wanted to write it down in one expression, that's what the expression would have to look like. First, I have to do the subtraction this says, and then I can multiply. So then I can just plug that sucker in. Now, any ideas about the benefit of writing it this way as opposed to do it in 2 stages like I did on the other page? What's that, Matt? You just plug it in one shot to a calculator. Even better, anybody know what my favorite kind of calculator is? Not my brain, no, I make mistakes in my head all the time. It's a spreadsheet. And on the spreadsheet, this is probably the way I would do it on a spreadsheet. Other thing is, if this is something I need to do over and over again, like maybe computing taxes or some other job I might have that requires this kind of calculation, all I have to do is plug the formula in once and I can just reuse it over and over and over again in the spreadsheet. And so I'll show that in just a little bit. So here I could just type that into a calculator as is, and I should get the 13,050 from that. So I'm going to bring up my Google calculator, and then we'll move on. So according to my work, I should be able to type 0.15 times parentheses 97,000 minus 10,000. I think I have enough zeros there. And there's my 13,050. All right, so I think we're going to start taking a look at the worksheet now. So if you have that available, take it out. So some things we're going to get used to here. We're going to play around with variables and algebraic expressions in order to kind of generalize how this income tax stuff works with formulas. We're going to get used to ideas like gross income versus adjusted income versus taxable income. And those are 3 different things, and we'll play around with those calculations. And then there's going to be a bunch of problems in this, and then on the homework where you're given some tax information, kind of like that story problem we just did, and you need to figure out which numbers you need to use in which order, right? And so we'll spend quite a few days working on this because it comes up in future lessons also. All right. All right, so let's look at the information for this situation here. We've got a married couple with no kids filing jointly. No one can claim either as a dependent. Together, they earn $93,000 of wage income. And so usually the $93,000 of wage income combined with other stuff is what we call gross income. So if they had any investments or savings account that paid a significant amount of interest, we'd have to add that in. If they received any big gifts or won anything recently, we'd have to add that in. But here it says they have no other interest or other income. Okay, so
how much do you have to have it qualify as other income?
What's the lower boundary for having to pay taxes?
Yeah, 'cause, I mean, you can get up to a certain amount and not have to pay taxes on it.
Yes, if you're below a certain threshold, you don't. You're still supposed to file, even if you don't have to pay income taxes though. And I don't know what that threshold is, but I can make a note to look it up and we can take a peek.
Something like how much I got for graduation and it wasn't enough,
I think it's like $1,200.
I didn't file it.
You think it's like 1,200?
That's what I think.
Okay. Yeah, I haven't thought about that since I was in college, so I don't remember. But I'll take a peek because that's something to think about. So this is a simple thing, so they can use the 1040EZ form, which is not bad to fill out. Anyone here filled that one out before? Okay.
Filled out a form on which one.
Yeah. So even if you're filing with not even paying taxes, you should probably fill out the 1040EZ each year. It's a good idea to do.
I filled one out for my summer job. I don't know which one.
You filled one out for a
A
job?
job I had over the summer, but I don't know which one it was.
Yeah, so I'd say what's the form you have to fill out when you get a job? W-4, yeah, and then W-2 is what they give you at the end of the year, saying this is what you made, this is what we paid in taxes, and then you do whatever you want with it. So for many years, I didn't make enough money to pay any taxes. In some years, I was responsible and I filled out the form. Other years, I was not responsible and I didn't file. This is being recorded on the internet. That was 30 years ago. Okay. Hopefully I won't get audited 30 years back. So let's see. So we're going to try and fill this out based on that company's and this couple's information. So wages, salaries, tips, All that added up is what we call gross income. And they only have 93,000. So in line 1, we just have a 93,000 there. And I'm going to copy this into my workbook. Page screenshots. All right, so we've got 93,000 so far. And we had no cents. Taxable interest, if the total is over 1,500. Okay, so this answers part of our question. So this is a few years old though, it's not the newest tax form. So a few years ago, it was 1,500 was the threshold. Okay. Let's see. Oh, taxable, sorry, I'm misinterpreting what I'm reading. This is taxable interest, I read it as taxable income. If there's any taxable interest, so like from some investment that you made, if it's over $1,500, you can't use this form, you're going to use a different one. So did they have any other income, interest income? They said no earlier, so that's going to be a 0. From there.
What would interest income be? Like, what would that?
So, for example, do I have any interest income? No.
Interest from the bank, if you have a bank.
Yeah, if you have a bank account with a lot of money in it, and the bank paid you, $10,000 last year because you have so much money in your savings account, or if you invested money in some kind of portfolio that's not a retirement fund, any interest that dividends that they paid you.
Oh, okay.
So this is from investments.
To get $10,000.
CDs, yeah, it could be, yeah, you cashed a CD out, you made some. What's that?
To get $10,000 of interest from the bank, wouldn't you have to have quite a bit in that bank account?
Yeah, since most bank accounts only pay like 0.5%. Yeah, let's see let me calculate that. If we got $10,000 in interest from a savings account that paid only 0.5 cents,
All in one bank account.
that would be 10,123 divided by 0.005.
Yeah,
Is a
it
0.5%.
really went down.
That would be what? That means you had $2 million in that savings account.
I don't think I'd put that much.
Yeah, you'd probably put that money somewhere else. Yeah, if you had $2 million, you could get more than 0.5% on it. Yeah. Okay.
It's like 10-year CDs, get like 2.75 or something.
Yeah, that's
You
pretty good.
gotta put in at least like 10 grand.
But you got to put at least 10 grand. You got to leave it in for a certain amount of
10
time
years, I think.
to get the interest. Okay, unemployment compensation. They have nothing else, so that's a 0 too.
What's Alaska?
Alaska permanent fund dividends. I think if you're a Alaskan citizen
You
or
get money.
you get a resident, yeah, they pay you for living in the state because the state makes money off the land in terms of oil and other stuff.
Oil.
Nice, I guess.
So congratulations, you lived through winter.
Yeah. All right, let's see. Add lines 1, 2, and 3 together. Not too bad. Still 93,000. Okay. If someone claimed you or your spouse at the joint return as a dependent, check the applicable boxes below and enter the amount from the worksheet. Okay. They said they couldn't claim each other. No one else was claiming them on the second line above.
And probably no
So
one else.
We can't check either one. If you can claim you or your spouse if it's a joint return, enter 10,150 if you're filing single, or enter 20,300 if you're married filing jointly. So they are married filing jointly. No one's claiming them as dependents. So then we get to put what here? $20,000, 300. Yeah. So 20,300.
The chances of someone claiming your spouse aren't very likely, right? 'Cause
Well, if you got married really young, the parents might be still claiming the husband or the wife. Possibility. So that happens. All right, so do that subtraction. What do we get?
when you can claim somebody. I think it's not like
72,700.
Isn't there an age limit to when you can claim people?
I think it's only up to, well,
If
Because
you're
I know my
not hoarding
parents,
more than half of all of their stuff, you can claim.
yeah, I think it can go on. I think it can go on indefinitely. Yeah, I
I know
don't
there's
think
something my
like-
parents like.
Usually, if you want to start claiming yourself at a certain point for financial reasons, Like for me, it was better if my mother didn't claim me when I was in college, because then since I was broke, I got more money to go to college.
Is it tax return? Like, can you get tax returns on your kids' things?
Can you get what?
I wish there was something like when I turned 18, my parents had to stop. Like,
Child tax credit.
yeah.
Oh, yeah, so so the child tax credit is something else. Yeah, that's different than claiming somebody as a dependent. So that's in addition to the deductions you get claiming somebody. Yeah, so that's more complicated than we're getting into with the tax stuff. Okay, so, sorry, Kristen, what was that subtraction again? 72,700. All right. So this right here is what they call the taxable income. So I'm just going to write a couple of notes on here as a reminder. This 93 right here, that would be gross income. So that's everything you made money on in a year. This number up here, they call the wage income. And then this last number down here, that's what our taxable income is. So we got wage income, we got gross income, we got gross adjusted income, we've got taxable income, so all these different terms to keep track of. All right, where are we at on this? I think we're ready to turn the page.
I have a question about that.
Yeah.
I know we're not right there yet, but what does it say? It says inequality, compound
Inequality. Yeah, I'll go
right
over that right now. Okay, so turning the page, taking a look at this part right here. Let me copy that so I can write on it. All right, so you would use the first line of the table to figure out the taxable income. So line 6 gives us that we take the value from line 6, and if it's at least 72,000 but less than 72,050, okay, then that falls into a particular line here. Let's see, where is that one? That's that first line right here in this table. So they want us to use T to represent the income from line 6. And so to write it as a compound inequality. Compound inequality is where you put the variable in the middle. So just a note, T here represents our taxable income. And according to the table, so I'm focusing on this line right there in the table, that top line. And our value for T, we can use that top line if it's less than the 72,050, but greater than or equal to, which is how you interpret at least 72,000. And so a compound inequality is where you have the variable in the middle and you have numbers on each side. And it's always going to go like this. The smaller number is going to go over here, and the higher number is going to go on that side. And as far as the inequalities, it's got to be a less than or equal to there, and a less than or equal to there. Now for this table, the lower number means you're in that row still. The upper number means you have to jump to the next row. So if they made $72,050, then we would have to use the next row to calculate their income. That bumps us. Okay. Does that make sense? Sort of? We'll do this again tomorrow. We'll get used to it. Okay, so then they want us to use the table provided to determine what they owe. So are they single or married joint?
Married.
They're married filing jointly, so that means we want to use this number right
You
here.
don't pay less if you file jointly.
Then singly, yes. So that's why some people say, it's a tax benefit to get married. Okay. So then the tax owed is 9,800, and I wrote over, is that a 96? Can't read it. 896.
There's certain situations where it's beneficial to separate.
Yeah. Yeah, it's a strange tax system we have. All right, so you can calculate your income tax in two different ways. You can, there's a long way to do it, which we'll play with later and see how close we get. And then there's the short way to do it, is where you just find out where you live in the table. And the table is actually much bigger than this. It's a whole bunch of pages of numbers and numbers and numbers for incomes that you can use. So we are not going to move on to the next part. The next part is where we're going to try and figure out the tax by reasoning through a bunch of steps, kind of similar to that story problem we did earlier. We're going to do that in class tomorrow, and we're going to try and do it on a spreadsheet. So tomorrow we're actually going to meet in the open lab instead of this room. I'll have a projector set up so you can see me on the computer, but I want to get everyone on a spreadsheet. So if you haven't already, get working on the prep assignment. I'll get your tests ready for you tomorrow so we can start on a redo of anything that didn't go right. And then we'll finish off lesson 2.1 tomorrow. All right, have a good day. Thank you. Do you feel well enough to do it today, Aaron?
I can do it today.
Okay, what time is good for you?
Anytime before or after 2.
You don't have class right now?
No.
Okay, right now would be good. And then you can use all of your worksheets on it. And let's see, do I still have any of your worksheets, or did I give them back to you? And then you need to give me any worksheets you haven't given me yet today. Let's see any of yours in my folder. Does that sound right?
Yeah.
I've given everything you've given me, I've given back?
Yeah.
Okay. All right. So, and then you've got your own computer. The last problem requires you to use a spreadsheet, so you can use your computer on that. Otherwise, you don't have to use a spreadsheet. So let's just go off into the other room. Just gotta clean up my mess here. Oops.